Hey, today we're looking at the Unit 5B review over solving polynomial equations. I'm hoping to be able to make this pretty quickly, so if you need to, please pause the video, rewind it, that way you can look back at each of these questions to get a good understanding to be ready for the test. So our first one that we've got wants us to divide and then, if possible, factor what we had remaining. So I'm dividing by x minus 7, so I can do synthetic division here. So 7 is going to go into the box, and then I need to put the coefficients out in front. So I've got 1, I don't have any x cubed, so I would put a placeholder of 0, and then negative 48 for the x squareds, negative 8 for the x's, and then just 7. When you're doing synthetic division, remember that first number just drops right down. You don't do anything to it, that number just drops down. And then I'm gonna multiply that by 7, because that's what's in that box there, and it goes there, and then I add these. 0 plus 7 gives me 7. So 7 times 7 is 49. Negative 48 plus 49 is 1. 7 times 1 is 7. Negative 8 plus 7 is negative 1. 7 times 1, 7 again, giving me a remainder of 0. Now, it's important to note, when I'm doing normal synthetic division, I do not have to get a remainder of 0. It just so happens that that is the case here. So I take 1 degree lower than what I started with, so it's a power of 3. That's going to be x cubed plus 7x squared plus x minus 1. And now this will not factor further. If I try grouping it, it's just not going to give me equal groups. It's not going to factor further. So that is it completely factored. Looking at number 2, I divide this. So I'm going to put a 6 here. And then I've got 8, negative 48, 0 because I don't have any x squareds, negative 1, and 6. I drop right down that 8. 8 times 6 is 48. That gives me a 0 there. 6 times 0 is 0. 0 plus 0, 0. 6 times 0, 0. Negative 1 plus 0, negative 1. 6 times negative 1 is negative 6, giving me a remainder of 0. And again, I go 1 degree lower than I had, so that would be 8x cubed. Then I have no x squareds, no x's, so just minus 1. Now this can factor further, and I need to note that that is what we have here, a difference of cubes. So that can factor, and it would be 2x minus 1, 4x squared plus 2x plus 1. Knowing that 8x cubed, so that a value would be 2x, and my b value would be 1. I just fill it in the pattern. So this is the division, arrived me to there, but that could further factor, and it would factor as that. The majority of these, you'll be using your calculator on the test, doing the synthetic division. Okay. So we've got x to the power of 4 plus 64x equals 0. So I can put that into the calculator. So I have x to the power of 4 plus 64x. And I can graph it. Now, I know it has a degree of 4, so I should have 4 total roots. And I'm looking at the graph here. I can see that it passes through twice. So 2 of them are gonna be real, meaning that 2 of them are going to be imaginary to give me up to that total. Now my real ones, I can look and I'm trying to find when y equals 0, and it happens at 0, and it also happens at -4. Those are the values that you would put into the box there. So now I've got 1, 0, 0, 64, with another 0 because I don't have any just plain numbers. So the 1 comes down, so that's -4, -4, 16, 16, -64, 0, 0, 0, no remainder. So that would give me x cubed minus 4x squared plus 16x. But I also had that factor of 0 there, so I can go another time through. So I'm going to just do that from here. So that 1 comes down, 1 times 0 is 0, -4 comes down, 0, 16 comes down, 0. So I have no remainder. Now this leaves me with x squared minus 4x plus 16. So my factors, one of them came from this. That's going to be x plus 4. Another factor, if I had a 0, another factor is going to be just x. And then I have another factor here of x squared minus 4x plus 16. So my real roots were those real values that I found. -4 and 0. To find my imaginary roots, you would need to plug it into the quadratic formula. So you'd have your a value is 1, your b value is -4, and your c value is 16. So plugging that into the quadratic formula there, and so let me get my color here. So that's going to be 4 plus or minus the square root of 16 minus 4 times 1 times 16, all divided by 2. So 4 times 16 is 64. So I have 16 minus 64. I've got 4 plus or minus the square root of -48 over 2. Sorry, I'm off the page. Didn't realize that. Square root of -48. That is 16 times 3. So I would have 4 plus or minus 4i square root of 3. The I, because it was under, I had a negative under that square root, divided by 2. That's going to simplify. So I have 2 plus or minus 2i root 3. And that does give me those 2 imaginary roots. So with this one, again, you're going to put it into the calculator. So you've got x cubed minus 2x squared minus 63x. You graph it. So there's going to be 3 roots. And I see that all three of them pass through there, so they're all going to be real roots. So I don't have any imaginary roots. So I can come to the table, and I'm looking for when y equals 0. So it happens at 0, meaning that's going to be a factor of x and a real root at 0. It also happens at -7, y equals 0. So another factor, if the root is -7, the factor for that is going to be x plus 7. And it also occurs there at 9. So the factor is going to be x minus 9. So I don't have any imaginary roots. On this one, you're able to find all of those roots in the calculator, so you don't have to do the synthetic division, and there are the factors to go along with each of them. So we've got x power 4 minus 16. When I graph that, I find 2 real roots, one at 2, one at 2, one at -2. So those factors are going to be x minus 2 and x plus 2, respectively. But I need to have 4 total roots, so I need to figure out what would be remaining. And so for this, I do synthetic division. So I choose one of those numbers, one of those zeros that I found. So I'm going to start with the 2. That goes there. And then I fill in. So I have 1x4, no x cubes, no x squareds, no just x's, and then -16. The 1 comes down, so that's going to be 2, so that's 2, so that's 4, so that's 4, so that's 8, that's 8, that's 16, giving me a remainder of 0. Now when I'm doing the synthetic division of finding those factors, that's when it does need to be 0. So I had a root at 2. I also have a root at -2. So I do it again using that value. The 1 comes down, 1 times -2 is -2, so that's 0, so that's 4, so that's -8, so that's 0, meaning I'm left with x squared plus 0x, so I don't have to write that, plus 4. So here is where my imaginary roots are going to come, because I'm going to set this equal to 0. So I have x squared plus 4 equals 0. And this I can do the square root method to figure out. So I'm going to get the x squared alone. I subtract 4 from both sides, and then I take the square root. So x equals the square root of -4. When I take the square root of a negative number, it has to be I. So that's going to be x equals I, and the square root of 4 is 2, so it's x equals 2i, but I need to have it as both the positive and the negative. So my imaginary roots are going to be positive and negative 2i. So with all of these that we're doing of this type, you start by putting it into your calculator to find the factors that you can see in there. So I've got x cubed plus 5x squared minus 4x minus 20. I graph it, and I see that it passes through here at -5, here at -2, and here at +1. I can look at the table and, +2, and find those same values. -5, y is 0, y is also 0 at x of -2, and y is 0 again at x of +2. And I'm gonna have 3 total zeros because that's my degree. So my real zeros are -5, -2, and +2. So my factors then are going to be x plus 5, x plus 2, and x minus 2. But I'm not going to have any imaginary roots. This one I didn't need to do the synthetic division because I was able to find all of those roots, all of those in the calculator. On to the next one. We've got 5x power 4 plus 8x cubed minus 9x squared minus 8x plus 4. So when I graph this one, I can find the zeros I have at -2, at -1, and at +1. So when I graphed it, that's those 3, but I have another 0 that I'm gonna need to have to find. So here I am gonna have to do the synthetic division. But I can write down those zeros that I had of -2, -1, and +1. And just take any one of them. It doesn't matter which one you start with. I'm gonna start with -2 and do the synthetic division. So the 5 drops down. 5 times -2 is -10. So that gives me -2. Give me +4. Gives me -5. Which gives me +10. Which gives me +2. It's going to give me -4 there, so I have the remainder of 0. I can do it again using the next 0 that I have. So -1, do it again. 5 goes right down. So that's 5 times -1 is -5. Add those, gives me -7. Times -1 is +7. Add those is +2. Times -1 is -2. Add those, gives me a remainder of 0, which I should get on each of those. I'm gonna do it one more time using this other real rational root that I found. So I've got 1. So the 5 comes right down. 5 times 1 is 5. That's -2. So that's -2 to give me 0. I started with power of 4. So here would have been power of 3. Here would have been power of 2. So this is just a power of 1. So I have 5x minus 2. And that's going to be one of my factors. 5x minus 2. My other factors come from these zeros that I used to do synthetic division. So if I had a 0 at -2, that means that's going to be a factor of x plus 2. If I had a 0 of -1, that means I'm going to have that factor of x plus 1. And this 0 at +1 tells me I'm going to have a factor of x minus 1. Now, these three, I already have found those real roots. To find this real root, I need to set 5x minus 2 equal to 0 and solve for x. So I add 2 to both sides. 5x equals 2, divide both sides by 5, and x equals 2/5. So that is another real root that I have. And I don't have any imaginary roots here because I got all 4 of them, and that's how many I need. Okay, so number 8. Once again, we need to put this into the calculator. So you're going to type this equation in. So I've got 5x power of 4 plus 44x cubed plus 106x squared plus 52x minus 15. Okay, so this one, it crosses 4 times, and it is a degree of 4. So all of my factors, or all of my zeros are going to be real. I'm not going to have any imaginary roots. And I can look at the table. So to get there, you press second graph and it pulls up the table. And I'm looking for when y equals 0. So I've got -5. That's one of my real roots. I also have -3 and -1. But I'm missing one of them, so I'm gonna have to do the synthetic division to figure out what that is. So these 3 give me factors of x plus 5 for that -5. This -3 gives me x plus 3. That -1 is going to give me x plus 1. So when I do the synthetic division, I'm using the roots. So I've got a -5 there. I put my coefficients out: 5, 44, 106, 52, and -15. I don't, in either of these, have any missing terms. That's why I didn't have any 0 placeholders. The 5 comes right down. 5 times -5 is -25. 44 minus 25 gives you 19. 19 times -5 is going to give you -95. 106 minus 95 is 11. Times -5 is going to be -55. 52 minus 55 is -3. -5 times -3 is 15. Give me that remainder of 0. So that took care of that factor. Now I need to do this one, which is that 0. So I have -3 that I'm dealing with. So the 5 again drops down. -3 times 5 is -15. 19 plus -15 or minus 15 is going to be -4. -3 times -4 is +12. Sorry, that's not supposed to be a -4. That's a +4, making this -12. So that's -1. -3 times -1 is +3. Give me 0. Again, that took care of that 0 and that factor. So now I have this last 0 of -1. The 5 comes down. 5 times -1 is -5. That gives me -1 to 1 to 0. So my other factor is going to be 5x minus 1. So to find my other real root, set that equal to 0. And I get x equals 1/5. So I include that there with those real roots. 9 and 10, we're wanting to know the total number of roots. So I'm looking at the highest exponent, so that is 4. So that's the total roots I'll have. To determine how many of them are real and how many of them are imaginary, I put it into the calculator. 10x power 4 plus 33x squared minus 7. Graph it. And that's what it gives me. It only crosses 2 times. So I have 2 real roots. The number of imaginary roots is the total minus the real. So that's going to be 2 imaginary roots. On this one, highest degree is 5. So that is my root total. To figure out the real compared to the imaginary, type the equation in. So I've got 45x power of 5 minus 30x power of 4 minus 3x cubed plus 2x squared minus 18x plus 12. So for how many times it crosses the x-axis. Okay, so it crosses 1 time here, and then here it crosses through, moves over just a little bit and crosses back through. So I have 3 times that it crosses. So that gives me 3 real roots. So 5 minus 3 is 2 that are going to be imaginary. (11 and 12). 11, 12, 13, and 14 are, well, 11, 12, and 13 are more of the same of put these into the calculator to get your factor form. I am not going to do these 3. We've had quite a few of those, so you can look back at those other ones to get examples of that. 14 has it worded slightly different. It just wants the x-intercept, or intercepts, which is, again, the same thing as those 0 values, but it's only wanting the real ones. So I've got 6x cubed minus 12x squared plus 8x minus 16. So when I graph that, that's all I've got. It's just that 1. So I can just say it has 1 x-intercept of the point 2, 0. Because that's where it crosses the x-intercept. The x-axis is at the point 2, 0. Now the instructions for the next ones are actually right here. We're going to write the equation given the zeros, but it wants them in standard form. So it's telling me that I have zeros of 2, 7, and 3i. But if I have an imaginary, I need to have both the positive and the negative. So not only do I have 3i, but I know that I also am going to need to have negative 3i. Even though it isn't explicitly told me, you need to know that those come in pairs. So if these are the zeros, to get it to standard form, you need to start in factored form. So you've got x minus 2, x minus 7. You have x minus 3i and x plus 3i. Always, always, always start with your imaginary pairs, foiling those first. That's all we're doing on these to get into standard form is foil it. So when you foil these, you have x times x gives you x squared, x times 3i, so plus 3xi, and then minus 3xi, and then minus 9i squared. Those cancel out, so you've got x squared minus 9i squared, but I squared is -1, so that's x squared plus 9. That's what you have there. Then you could FOIL those ones together. So I've got x minus 2 times x plus 7. So that's going to be x squared minus 7x minus 2x plus 14. And when I combine like terms, that's going to give me x squared minus 9x plus 14. And then you need to multiply these that you just got together. When you do that, you're going to distribute it to all parts there. So x squared times x squared gives you x power 4. X squared times 9 is going to give you 9x squared. Negative 9x times x squared is going to give you negative 9x cubed. And then minus 81x. And then 14. So plus 14x squared, and then 14 times 9, so plus 126. Combine your like terms and put it into the correct order from highest exponent down. So you'll have x to the power 4 minus 9 x cubed plus 23 x squared minus 81x plus 126. So when you're doing these, you've got to FOIL it, and FOIL it again to get what you have. For 16, once again, if I have a 0 of -3, that factor is going to be x plus 3. If I have a 0 at 8, that factor is going to be x minus 8. The only one that's a little different is a 0 at 0. That factor is just going to be x. So here, I'm going to need to FOIL these ones together. So that's going to give me x times x is x squared minus 8x plus 3x minus 24. Combine like terms, x squared minus 5x minus 24. But then I need to multiply all of that by this x. So when I multiply that by x, really I'm just adding an exponent onto all of them. So I've got x cubed minus 5x squared minus 24x. So I've got y equals that. 17 and 18 are more that are similar to 15, where you've got an I, so you need to remember that you have the negative part there. So you'll have not just 4i, but negative 4i. And not just 5i, but you'll also have negative 5i. So I'm gonna leave those two for you to work on yourself. Want to take a look at number 19. I'm going to leave number 20 for you to try. Here we're doing long division. With long division, you put out in front what you are dividing by. And then under that division thing, you're going to put what you are dividing, the entire thing. When you start, you only care about the beginning. What do I need to multiply 5x by so that it equals 5x to the power of 4? That's going to be x cubed. But then you multiply that by both of those. So that is 5x power 4 plus 7x cubed. And then you subtract So 5 minus 5, those are gone. Negative 8 minus 7 gives me negative 15 x cubed. And then I drop my next term that I'll be dealing with. And I go again. 5x to get to negative 15x, I need to multiply by negative 3x squared. So I multiply both of those. So that's going to be negative 15x cubed minus 21x squared. When you subtract a negative, what you're really doing is adding. So I've got negative 15 plus 15, those cancel. Negative 11 plus negative 21 gives me positive 10x squared. And I drop down that next term, minus 21x. And I go again. 5 to get to 10x squared, 5x to get to 10x squared, it's going to be plus 2x. That's going to be 10x squared plus 14x. Subtract those 10s cancel. Negative 21 minus 14 is going to be negative 35x. And I drop the minus 50. 5 to get to negative 35 is going to be negative 7. So that's negative 35x. Negative 7 times 7 is negative 49. When I subtract those cancel. But negative 50 plus 49 leaves me with negative 1. I don't have anything to drop down. This is my remainder. So in total, that's going to give me x cubed minus 3x squared plus 2x minus 7 plus, and then I have that remainder, so negative 1 over whatever I was dividing by, 5x plus 7. Okay, so there are still a few on here for you to work out and be able to finish so you can be ready for the test.